so that in recording it will be okay everywhere.
Yeah, I am already on only camera.
But that camera is on to the your might be to the other number then.
Okay. Now it's okay.
Yes, fine, fine. Please start.
Okay. Very good morning to all, one and all.
Good morning. Please.
First of all, my thanks to Dr. Sanjay and Dr. Bhagavat, Head Mechanical Engineering, Head of Department Mechanical Engineering, and Dr. Hussain, Head of Department Electrical Engineering, and Mr. Kade and Mr. Jamadar for arranging this short-term training program. My presentation, shall I start now?
Please. Yes, sir, please.
Yeah, I'm going to present about this energy conservation in air treatment and control systems. So air treatment and control in the industrial manufacturing plant and process, we are going to talk. It's complexity due to the ambient temperature, humidity conditions, and that is dust level, as well as there is energy involved in the removal and addition of heat. So proper understanding of requirement of inside environment control, selection, operation, maintenance measures will lead to energy conservation. So continuous efforts are going on in the manufacture of energy efficient products at different levels. I think last 2 days we have been hearing about the motor, how it has improved in the energy efficiency of the motors by Mr. Srinivasan sir, and also Sivaraj sir about other electrical equipments. And so I'm not going to delve much on the equipments which have already been presented and going to be presented. So right selection along with combined effort of the designers, planners, contractors and engineers can bring down the cost of total ownership. Is it moving, sir?
No, sir. No,
not
just
moving.
the first. No.
We are in the first
Oh,
slide.
it is not moving. Yeah, we are
So
still in first slide, but I'm.
Sir, can you try once again, sir, about that full screen so that you can present? Now it's okay. Yes. Now it's moving, sir.
Yes. So this presentation is to highlight the some functions of the air treatment and control system, and some case study, 1 or 2 case study I'm going to show in the presentation. So basically this process of treating air to simultaneously control one or more of the following, that is temperature, relative humidity, ventilation, air motion, dust and odor. So air conditioning does that work total. One or more, it is handled by air conditioning. So if you see the type of air conditioning, there are comfort air conditioning, that is for the people, process air conditioning, that is for the product in the manufacturing process. Year-round air conditioning is there. Summer air conditioning. Year-round air conditioning means that is irrespective of the outside condition, you want to maintain certain temperature and relative humidity and other parameters. Summer air conditioning means particularly you want to maintain particular temperature in summer, that is you want to cool it. Winter air conditioning, you will have the extreme outside lesser temperature, you want to maintain certain temperature. So we have a different air conditioning, that is refrigerated air conditioning, that is a direct and chilled water air conditioning, and evaporative air conditioning, direct and indirect. So in the air control system where we have to ventilate the air inside the industrial area where process is going on. So just to remove the exhaust, remove the hot air or fumes or dust and from the production machine, and necessary ventilation is achieved when fresh air is drawn. And important things are volume of air, velocity of the air, distribution of the air changes, and positive pressure, negative pressure. So I'm going to tell on about the industrial ventilation case study, as well as process of treating air. That is one case study. Then some basics about the design consideration and the manufacturing projects. So it is an overview I want to give. So not much on the energy audit side or something on the equipment side. So first we understand properly how the air treatment is happening, air control is happening. We can easily do justification on the energy saving and energy conservation. So we have different in air conditioning, you know, refrigerator compressors are there, chillers are there, condensers, cooling towers, air cooled condensers, pumps, piping, AHU, fans, filters. So when I checked, there's a gentleman is going to talk about, I think tomorrow, Mr. Kamala Kannan, about pumps. So I'm not including much on the pump and pumping system. So industrial work environment are very much complex due to the operation process, usage of chemical compounds and substances. So substances in the process may cause particulate gases, vapors in the work zone air in the concentration, and may cross the safety level also. So heat can also result in unsafe and uncomfortable environment. So some of the nature of contaminants in the industry, you can see vapor, gases, smokes, fumes. Then the welding fumes will be there, air laden with fine dust, dry dust and powders in the leather shaping, etc. Then average industrial dust, you can see the grinding dust, general material handling dust, brick cutting one, limestone dust, and heavy dust we can see in the sawdust, metal turning, and heavy moist dust also we can see. So what is the necessity for the humidity control in the industrial process? Industrial process, I consider the manufacturing process of any industry. So product moisture content loss or gain is there, rate of chemical reactions, rate of biochemical reactions, then the rate of crystallization, static electricity, accuracy, uniformity, and overall product quality. These all the humidity control will help in these things. Then necessity of a working temperature in certain industrial process and machines are electronic parts will be there, microprocessor will be there, components will be there, which require certain minimum temperature. Product requirement will be there for certain manufacturing product, and it will help productivity also to speed the machines. Certain temperature is better. So human comfort also is there. So some terms about air conditioning, I want to little bit cover this. This is a change. Ventilation is change of air or replacement of indoor air by fresh outdoor air at a rate. Either CFM we call cubic feet per minute, or CMH cubic meter per hour. So purpose is to provide oxygen minimum 25 and 21% by volume and shouldn't fall below 15%, and 0.03% CMH for light work and 0.15 CMH for heavy work. And carbon dioxide shouldn't rise above 5% in any industry. Heavy activity and smoking 0.7 to 1.1 CMH per person is recommended. To remove the odor, 0.42 cmm fresh air per person is required. To remove the heat and humidity, sick building syndromes are there. Sometimes you same stale air is keep on recirculated. Because of that, you go to the factory, you will be well at home. When you go to the factory, you will face these problems. So why air filtration is required? To protect the occupants, contents, and inside environment, to protect the air conditioning equipments, to protect the building environment, to eliminate fire hazard by removing the lint and foreign parts which might accumulate in the ductwork, and to remove the create a dust-free ambience in the inside the factory. That's why we require air filtration. So as I initially told, the air treatment of we are a combination of many things, that is ventilation, air circulation, temperature, RH control, and filtration. So this air filtration we are talking about 1 micron, as everybody knows, 1,000th of a millimeter. Thickness of a human adult air is 100 to 150 microns, and visible is about 50 microns. We can see more than that we can't see. So there are different pre-filters recommended in the air conditioning system. So this all the parameters what I told is all important to understand the air conditioning overall where the energy goes. So pre-filter up to 10 to 20 microns, it can handle. Fine filter 3 to 5 microns, super fine 0.5 microns at 85% efficiency, and HEPA filters, you all know. Then ULPA filters, ultra low penetration particulate air filters, high efficiency particulate air filters, and various standards are there. MERV standards and federal standards are there. ASHRAE standards are there. American Society of Refrigeration, Heating, Air Conditioning Engineers. That's the standards are there. Why we need to control the temperature? What are the temperatures? You can see the dry bulb temperature, wet bulb temperature, ambient temperature, that is outside. Then working temperature, you need certain working temperature for the product or process. Then process temperature, human body temperature 37 degrees centigrade, you all know. There is a different type of heat transfer takes place: conduction, convection, radiation, evaporation. And relative humidity, we see as a percentage relative humidity. Then absolute humidity is there, that is exact moisture content, grams per kg of dry air is absolute humidity. Then ambient humidity outside. Then process humidity, you need maintain certain humidity, that is the process humidity we call. So human comfort level, we can manage 50 to 70%. So air motion, as I was telling you, velocity of air, and this is the important for the air movement. Then either in meter per second or feet per minute, and diffusers it will use to diffuse the air, and or air outlets, grills are there. So we need to understand what is the psychrometric process. Once we know this is the psychrometric process, then we can be able to understand why this air conditioning is given to this particular industry, and majority where the power is going. So, psychro means cold, metric means measurement. Psychrometric is study of the thermodynamic properties of the air and water vapor, simply study of solubility of moisture in different temperatures and contents. So you all knowing about psychrometric chart. Sir, mechanical, electrical, everybody is there in this. Hello? Am I audible?
Yeah, yes, yeah, mechanical as well as electrical. Both are there.
Okay.
Please,
yeah, okay.
Please carry.
So you can see the in the psychrometric chart, you can see the dry bulb temperature, wet bulb temperature, then humidity, specific humidity, relative humidity, dew point temperature, enthalpy. I don't know whether this point we can see the points. So this is these are the points we can see. Just to overview I'm giving. See, basically, once we know what is the psychrometric process, based on that we can analyze the air quantity requirement and of the industry. Sensible psychrometric process, we have basically 8 process. This is very, very important. If you understand, then everything is fine. One is sensible heating, then sensible cooling, then humidification, dehumidification. Then we have heating and humidification, heating and dehumidification, cooling and humidification, cooling and dehumidification. So why that is required? So you can see there are different climatic zones in India: hot and dry zone, warm and humid zone, and composite zone is there. Very cold zones are there. You can see in the north side. Then moderate, you can see in Bangalore and some parts of Tamil Nadu. Moderate, you can see. So these are the zones where the outside climatic condition will change. Based on this only, the requirement of air conditioning will be there. So these are the external load: solar gain through glasses and walls and roofs, heat transmission through walls, partition, ceiling, floor, infiltration of outside air. All these things are considered for the heat load of the air conditioning station. Some of the solar heat load and other heat loads. So as I told you, there is a conduction, radiation, convection through heat transfer takes place through the walls and windows. So for each product, there will be a different coefficient of heat factor. For brick, it will be different. For wood, it will be different. For glass, it will be different. So internal heat load, heat load from the people. People give out some heat, and heat from the motors and machines, lights, appliances, and there are room sensible heat, room latent heat. Mostly latent heat means mostly it will be moisture. So we will see a case study on the evaporative cooling air conditioning, direct evaporative air conditioning. So this is a simple system. We have a fan. Then there will be spray banks. It will be spraying the recirculating water. Then there will be filters. Then there will be provision for controlling the air through dampers. There will be a provision for recirculating the air and take the fresh air. And there will be water drop eliminators to eliminate the water from the air. So basically, automation happens once the water sprayed there, and air mixes with the water, and it passes through the chamber, and it follows the adiabatic saturation principle, where the wet bulb will be remain same. Fresh air is taken out and first filtered, then brought into contact with the wetted surface through the spray. There will be a lot of nozzles will be there. It will be sprayed, and air gets cooled and humidified due to the transfer of sensible and latent heat between the air and water. So water, we consider it is the saturated temperature of the wet bulb. So it is saturated due to recirculation. The cool air is then supplied to the conditioned space where it picks up the sensible heat and latent heat and attain a room condition. This is what the system. So constant path, as I told you, saturated efficiency, we can go maximum about 95% efficiency on this. So you have the system inside. We have the spray nozzles here. So because you are in the Ichalkaranji, I've taken the one textile plant of weaving unit where this air can be supplied there. And I will show a case study where we have done the modification on the in the plant for improvement. I'm not going to tell this or the because everything is available. You know, this heat load, everything is available. So overall view only I told these are the parameters we should consider while doing the audit or evaluating the system. So more focus on the system. We understand the system, then other things, formula, and we can download a lot of websites are there about equipments. You can just check up what is the chiller is available, COP, and motors, high efficient motors available. Everything we can see in the. So once we know the system, these are the requirements. These are the parameters important for designing. Then as an auditor, as a energy conservationist, we can go and evaluate very easily. So that is why I am focusing more on this. So we have taken a capacity plant. If you see here, there are 85,000 cmh type A and type B given. So the air washer size of the width of 3.5 meters, height of 2.7 meters, and 4.5 meter is the length of the air washer chamber. So earlier there was in the initial there was a air distribution. You are seeing these blue color air intake louvers. Before that there was just this is for the example I had taken this. This is a new plant. So there is a perforated sheet like arrangement where will be holes, slots will be there. So that we have changed to PVC air intake louvers so that there is a smooth flow of air. And number of banks, spray banks were 2. And old system, there was galvanized steel pipe. You know very well the steel pipe, there will be a lot of this corrosion happens, as well as sediments will be there in the pipe. So we changed it to UPVC pipe, and nozzle arrangement was there. So this is the point I want to emphasize. See, even though we get the best of the equipment, once we the design is not proper, not considered in the energy aspects, whatever the equipment you put, there will be saving on the equipment only. But in air conditioning particularly, we have to see the design aspect is more. So the equipments are available, but the design part is much more. And it depends upon the owner as well as the consultant and as well as the designer in giving the product, not on the first cost, on the cost to the owner. So the PP nozzle were 8 mm modifiers were there, 96 nozzles were there, and we changed that single system pump to dual pump system. Dual pump we have changed it. I think now it is. So dual pump system, instead of single pump, it was working fully, and when the RH is reached, it will stop and it will switch on. So there, for a flexibility of operation, we have changed that into two bank independent spray pump system. Keeping other parameters same, like the flow of the fan slightly improved because of this lower change into lower, and the spray system, and the velocity almost same. And installed earlier kilowatt was 7.5 kW, fan motor was same, so now also is same. Whereas the pump capacity changed from 1125 liters per minute to 2000 liters per minute. Two pump system we installed, but instead of 7.5 kW single pump, 5.5 kW two pump system. Two pumps were installed. So because of this, there was with one pump, it will try to achieve the required temperature in RH. When there is a demand more, then second pump will operate. See, we should not see only the power saving on the motors, on the pump. What we change, pump again we change into energy efficient pump. Not only on that, design aspects, as well as the change of the nozzle design, as well as velocity, air louvers. Because of that, there was a change in the change in the power consumed. You can see this air intake and efficiency of the air washer previously, and now it has come to 92.6%. So it has improved a lot with the two pump system. When it is peak during daytime, it will work. Other time it will only work with one single pump. That provision was not there earlier. Like this, a lot of factories we have still without this, because in the energy audit side, people go and see how many pumps are there. Just you measure the pump and this one. But this design aspects, people will not be able to see much. So number of dampers and all these dampers, area and all, it is left to the designers. So slight changes can be done. So that's what we observed is increased airflow, then less pressure drop, effective spray spread across the air washer, then increase in the pump performance, increase in the fan performance, the flexible pump operation, as I said earlier. So less wear and tear. That is also maintenance, also one of the cost to the owner. So that is also important. And overall energy saving was about 22%. I think after change of the fan, it showed large opportunity for retrofit measures. There's a lot of opportunity for retrofit measures in the industry. Another also I can tell about the energy conservation in the dust extraction. So here I have seen this the speakers. Nobody's speaking about fans. I think pump already somebody is there, and other motors they have covered. About thermal and the instruments also have been covered. So I just that's why I added about the blowers and fans, the important heart of the ventilation system. The blowers and fans in the manufacturing sector consume around 25% of the energy used. Approximately 40% of the energy consumed by fans are wasted actually due to various reasons. Fans are used in the manufacturing process directly or indirectly. Some places for the conveying the material, some places for process cooling, some for the heat transfer, blowing. So in the air conditioning system, in the air handling, it has been used centrifugal fans as well as axial flow fans. So fans and blowers used for environmental pollution control. You have pollution control scrubbers where you use the fan before scrubber or after scrubber. So a lot of applications are there. So basically, what is the fans, blowers, and compressors? So all are turbo machinery, so rotating impellers. Fans are almost similar to pumps. So pumps handle liquid, whereas fans handle air. So specific ratio, as you know, discharge pressure by suction pressure, when the fans which work in the range of 1.11 of the specific ratio at 1136 mm of water column, it comes in the fan range. While blowers, it's about 1.11 to 1.12 up to 2066 mm of water column. Compressors, as you know, the high pressure compressors, it's more than 1.2. We call as a specific ratio, we call as compressors. It comes in the air compressor range. So air handling fans, the HVAC application, a lot of fans are used, even ventilation fans of industrial exhaust filter units for air pollution control equipments. So we can, different application, different fans are used. Broadly, if you classify, there are centrifugal fans and axial flow fans. For low pressure and medium pressure application and low volume application, both centrifugal can be used as well as axial flow fans can be used. Hello.
Yes, sir.
Is
Yes.
the connection lost? Is the connection lost? Where are we? Camera is off, but I am not. Okay, you can see.
We can hear you.
So in
we
my
can hear you only. Camera is lost. Camera connection.
Okay. But I am not able to see the shared screen. That's why.
Okay, okay. Here I can see. We can see that shared screen. That your slide is that
Okay.
energy conservation in air treatment and control. So that is visible.
That is okay. So nothing is lost, no?
Yeah, nothing is lost. I think here it's okay, fine for us. But for you, it is the connection is lost there.
No, connection is still there, but I am not able to see that PPT in the
Okay, laptop.
in my
Now
tab.
we
In
can,
my tab.
now we can see. Now we can see you.
Yeah, but I am not able to see the.
What we are missing is the bottommost portion of the slides. Some portion
Okay.
of it, one line, offline is getting missed.
Yeah, no, I already adjusted that with the percentage. I made it 77%. I think you will be able to see fully now.
Okay, now I'm thinking we are seeing fully. Okay, yeah, thanks.
No, I'm not able to see anything in the tab. Still, I think I am able to see in the laptop. I'll proceed. If anything is there, you can please interrupt me, sir.
Yes, sir.
So, yeah. Now it has come. So we have a different fans for the application, low and medium pressure, low volume application. We can use both centrifugal fan as well as axial flow fan. For high pressure and low and medium high pressure, low and medium volume application, we have to use only centrifugal fan. Low pressure and high volume, we have to use axial flow fan. So these are the axial flow fan and centrifugal fan. In axial flow fan, there will be axially the air movement will be there. So in axial, there are three types of fans. That is, one is propeller fans, other is tube axial fan, then vane axial fans are there. So propeller fan, just there will be impeller and fixed on the motor on the or the shaft. Tube axial, there will be a casing. There will be a casing for the impeller to run. In vane axial also there will be a casing, but again there will be vanes, guiding vanes in the backside before the start of the air movement. There will be vanes. So the vanes will guide equally the air to the impeller. So it is the most efficient fan in the family of axial flow fans. And in the centrifugal fans, we have a backward curve, radial curve, forward curve, aerofoil blades. Aerofoil blades, as Mr. Ashok Sethuraman was telling yesterday, is a most efficient one. There are a lot of retrofits can be done in the ventilation and air control systems. And the various application. Just broadly, I am telling, because if you know this right selection, some, as he told rightly yesterday, during the audit, he saw they were using just as a supplier given the backward curve fan and forward curve fan, they can use it aerofoil type, so that the efficiency of the fan is more and they save a lot of energy. So this understanding of the fan made him to observe that, and he was able to give a report that you can change this fan. I think he has done some his report, based on his report, they have done some replacement also and saved the energy. So that is why this efficiency, if you take a radial 70 to 79% and forward curve or less but it is suitable for clean application. But for material transport also we can use that. Backward curve used for forced draft and other 79 to 83%. So aerofoil type is a more efficient one. Same like a backward, but it's most efficient one. But we have to see whether that application suits. We have to ensure that the air is clean and there is no fluff or dust coming on that, because the gap between the impeller and the scroll and other things will be less. So all these things, parameters, we have to in detail we have to see before selection. So in as I said earlier, the propeller fan efficiency about 45 to 50%. Many places the propeller fan will be working. Some places even this cooling tower fan they will be using for some exhaust, which will be just for the namesake running without knowing the pressure and volume and other things. Then medium pressure tube axial about 67 to 72% is the tube axial. Vane axial around this is the most efficient one, 78 to 85%. So we have, once we want to observe the system, any ventilation or dust extraction system, we have to measure the existing volume. Then what is the static pressure, then total pressure, damper arrangement, how the damper after outlet they would have provided damper, that is what type of damper it is, then ducting arrangement, how it is given, fan clearance, pitch angle, the drive arrangement, how it is given, then pulley and belt arrangement, of course the speed is there, then inlet and outlet conditions, then operating condition, whether it is a part load or peak load. So internationally, there is an association called Air Movement and Control Association International Incorporation. So they given the significance of the flow quantity of air. So they promote about the energy efficient fans. So fan basically to study about the static and total fan pressure, energy used in the fan has two components, that is a dynamic and static. One is dynamic, there is a static pressure dynamic, then static pressure, then dynamic when the velocity is there, when the air movement is there. That dynamic pressure will give the will be the power of the fan mostly. Some of the both total energy is delivered by the fan. So the fan designer as the manufacturer is responsible for the fan energy efficient fan. So the AMCA members, they give certified fans and they follow certain rules in the manufacturing process. They will be evaluated, they will be tested and certified. They will be given some particular range. It has been tested and certified. AMCA certified fans are available in the market. It is an expensive process for the manufacturer to get the AMCA certified. So they should follow certain rules to get the energy. So that is why this energy efficiency one, you get the fan of energy efficient one. So I am going to tell the so just I'll cover this. The fan efficiency and motor efficiency, already we have a best efficient motor is available. Fan also you can select. Then fans must have peak efficiency, must be operated near to peak efficiency. So that we have to see whether it is a full load or part load, when you have to get that full volume and the pressure. So whether it is going to be continuously will be there in a day of 24 hours, it will be in 8 hours, or it will going to be 10 hours or 20 hours. So that we have to see. Then the energy consumption point of view is particularly that you have to see the while estimating each operating point, if you see the part load and full load and different production and load conditions, it will be better to evaluate the fan at a later stage, and we come to we can come to a conclusion based on that very easily. So this is what the fan curve. So normal operating conditions will be, so totally you see the static pressure here, you see the airflow here. So this will be maximum free delivery, that is a free air delivery. After the outlet, in the outlet, there will be free air delivery. So it will be there. So static pressure will be there. So in the fan curve, it comes in the center. The operating range can be plus or minus. It should operate within that range. Otherwise, there will be a loss of energy. So set of condition, restricted condition, less restricted condition. So like that, the graph is given. So just to understand the things, as you all know the fan, how the brake kilowatt is arrived, Q into total, that is Q is the volume of air and meter cube per minute, and total pressure of the air measured in the water column, and the total efficiency of the fan. So if you know what the brake, if you know the kilowatt and minus the efficiency of the motor, you can find the brake kilowatt. So indirectly, you can cross multiply and find the efficiency of the fan. Mostly efficiency of the fan nameplate will be there. With the nameplate, we can arrive the brake kilowatt. If it is not there, there will be a fan fixed. The motor is taking the load. There will be a current. You can measure the RYB, then voltage and power factor, everything. Then we can arrive the near to approximate efficiency. Based on other two parameters, we have to measure. Volume of the air we have to measure. Total pressure we have to measure, either in the outlet or in the inlet duct. So the affinity fan loss there, speed is, volume is directly proportional to speed. You reduce the speed, equally the volume will reduce, and pressure square is proportional to the speed, and power is cube of the speed. You reduce the speed, and 1/3 the power will reduce. This is available. Everybody must be knowing this. Anyway, and the benefit of the other people, I just mentioned this important fan loss. Yes, nobody's covering about the fan on this entire training session. I want to focus on the fan. That's why I included this. So volume of the air, total pressure, arrangement also very important. How you put the outlet. There will be a top outlet, there will be side outlet. Outlet will be 45 degree, 60 degree, and 90 degree. So that outlet is above the ceiling. It goes near the wall. All these will create a back pressure, and total simple during the audit we can find out there could be a lot of mistakes. While ordering the fan during the project, they would have, due to urgency of the commissioning of the project, they would have installed the fan, everything, but it will be a continuous headache. They will be it will be drawing more power. When we go for the audit, we can easily find out there is a small place we have to make the orientation change, so that their number of bends are reduced. Like that, if we do, easily there a lot of energy can be saved. I'll show an example how we have done. So in the dust collection extraction system, so basically design parameters are required. That is, what is the capture velocity? At what velocity you have to collect the fumes or dust? Then what is the air quantity? At what, how much air has to be removed from particular machine? Then at what negative pressure? There should be negative pressure. Then only air will start sucking and moving the material or dust, whatever may be. So then the layout of the machine, you will find in the manufacturing process layout, there will be a 50 to 100 meter area is there. There are different machines will be different location. So you have to collectively take all the air from the machines. So that layout is very important. Once you see the layout, then you know the distance from one machine to another machine. What is the distance, the air to travel, the duct sizes, and what is the diameter we have to give. So the modification on the what we have seen, what we have done is we have seen the entire duct layout, removed the sharp bends, avoidable duct roots, where when you have a 45-degree bend, the power will be less, the pressure drop will be less. If you have same 90-degree, 3 times the loss will be there for the same dia duct with the same velocity. So the ducts of uniform sizes, air volume and pressure, everything we have seen. So based on that, we have done the modification. Basically, how it happened is, initially there was number of machine were less. Maybe they were having 8 or 10 machine. They want to increase number of machine, but they can't change much on the fan side. So only option is, again, don't want to invest. Only option is you redesign the entire system so that wherever possible you can save the power energy, so that the same fan, same system, you are adding number of machines more. So it was economical, and there was a saving on the power also. One was for the same machines, we got the power saved. So here the dust extraction system, original layout was this, and after modification, type of the fan is centrifugal backward curve, the belt driven fans. Number of ducts, main ducts were 4. After modification, we made it 5 based on the air volume and the pressure drop across the same air volume and velocity. So redesigned the ducts, number of branch ducts, duct size is about 500, 600 mm. So based on the requirement, we changed the number of ducts and sizes, and capture pressure was minus 650 pascals, and volume of air of each machine like that. So total 60,000 cm volume was there. So length of the duct, because of this change in the layout and bends and things, it has reduced about 5 meters approximately. So total installed fan power was 55 kilowatt. Earlier it was consuming 50 kilowatt. So after this modification, it was consuming only 44.6 kilowatt. So about 10% approximately power was saved.
The power saving is mainly due to reduction of the dynamic pressure.
Yeah, dynamic pressure as well as static pressure, because static is based on the your duct sizes. Particular velocity, you are having the high velocity means there will be more pressure drop. Low velocity means less pressure drop. For particular air quantity and pressure, we have to see in the chart of the duct charts. Round size duct charts are there. There will be pressure drop on one column. Other one is volume will be there, other column. So we calculate for this particular CMH or volume. You see the pressure drop and the dia. The dia is all fixed. We are having a table like chart arrangement, like a psychometric chart is a chart for pressure drop chart is there for this ducts. If you check based on that, if you redesign, because originally they would have added that particular extra volume also, they would have added in the same duct. So because of that, more dynamic pressure will be there. So that got reduced, as well as for the required air volume. If you select the correct duct, then your pressure drop is less. So we redesigned that, and totally it has saved. And also the bends also, and wherever possible, we instead of 90-degree bends, we change the layout. We change the layout to shortest distance, and we have made. Earlier they were talking about aesthetics. It has to go for a long way and make a turn. So this aesthetic point of view, we told that whether you want aesthetics or power saving. So they said, the management said the power saving, okay, we can go ahead. So then we changed that layout. So that power saving was based on that, sir.
The discharge pressure has reduced after these modifications?
No, discharge pressure is not reduced, sir. Discharge pressure is not reduced. No, volume is same. Your static pressure, total static is reduced. No, your static has reduced.
So system resistance is reduced.
Yeah, system reduced. This is reduced about 300 pascal. I think 350 or 400 pascal. It has reduced. System pressure is reduced. And unwanted, they put flap dampers and all that. Unwanted flap dampers was removed, and this sharp bend was removed.
Okay, thank you.
So we have done in even in this automobile factory in one of the TVS groups. We have done in Brakes India. I remember Brakes and the place where they have given for air pollution control. Earlier, the capture velocity was more. Just they have given a very big fan, and you know that there will, in the process of machine, there will be acid and fumes will be there. So to capture the fumes and take it to the scrubber, they have installed a ducting system and fans. So once we redesign the ducts, redesign the capture velocity, which were away from the tank. The capture duct was away from the hood and all, away from the tank. So there it was trying to draw the air from outside instead of taking from the exact tank. So we reduced the height of the hood, put it near to the place where it has to remove the air, capture the fumes. Like that we modified. Then so it eliminated the outside infiltration of the air. So additional air, if you take in centrifugal fan, it will draw more power. So this kind of wherever arresting the leaks, all these things, even the ducts also, the duct contractor due to commissioning, they will do very fast. They will just this joint and seals, they will not do it properly. If you just measure all the leaks, that itself will save a lot of energy. So practically we have done that. So this is axial flow fans. Based on that, your total system, the axial flow fan, you can retrofit into 8 blade, 10 blades, high pressure fans, and work at low RPM. So this is the ducts. So overall, what I want to say is not only on the equipment, we get the energy efficient equipment, but we don't see the design and we don't understand the process and system. As in the morning, Mallikarjun sir was saying, more understanding the process is more important. As even yesterday, Mr. Ashok Chetram was telling, once we get the order for energy audit, we used to collect all the data of from the company, what kind of process, production. Then we go with all understanding and start analyzing the energy point of view. So not only particularly, but there are people, when there is a energy audit, even understanding of the industry also, energy audit, they will come immediately tell this transformer motor, we have to change, this is old inefficient motors, you change this will report why we have to go for audit. So that is why. But we, my experience, normally what I do is, I do the plant audit. Plant audit, particularly on the air conditioning only, we do the audit. So I used to tell them, what is the process, what is your requirement, what are the total your factory. There may be an identical industry, say industry will be same, but two factory will not be identical. One will be in Hyderabad, one will be in Maharashtra, one is in Tamil Nadu. But capacity, everything same. But in air conditioning, it is totally different. Your air quantity will be different because of the seasonal changes. We have summer, winter, other seasons. Like that, a lot of inputs will change. Because of that, your load will change. Even wall also. We see that this capacity, but a wall will be different. There will be a brick wall of 9 inches. Instead of that, 12 inches will be there. So coefficient of heat transfer will change for 9 inches and 12 inches. Roof height will be different. Fall ceiling height will be 1 feet height difference will make a lot of difference in the air changes. Instead of 12 feet, some places they have 14 feet, 2 feet higher the fall ceiling, your entire production all volume changes. Because of that, more air has to be treated air has to pump inside. More air, treated air is going outside for a change. So all these things, once we understand the process, the design aspects, not as a like OEMs, but at least we understand this entire system, we'll be able to offer better conservation results. So the solar heat gain to roofs and windows. Insulation also plays very important. Like simple by simple measures, lot of energy can be conserved. Like insulation, change in the insulation thickness, old the insulation and all 10 to 15 years old, they would have given some insulation in the false ceiling or ducting, that insulation would have gone. So now new technology, pre-insulated ducts are coming, as well as insulation with aluminum foil face is coming. So in old times they would have put just ordinary insulation and wrapped with some other thing. So these areas we can total load we can reduce, as well as natural lighting and building envelope also very important wherever possible. Their facade and as well as lighting arrangements, even light also. There are many glass available, which is low coefficient of heat transfer, low transmission glass are available. I think one Saint Gobain is doing that type of for large scale buildings, recommended by I think Green Building Council or this energy Bureau of Energy Efficiency. Based on that, glasses are available, as well as fan system also. There are a lot of scope. Multi-pump system, as we saw in the case study. Instead of single pump, we put multi-pump system, flexible operation, wear and tear, total ownership cost reduce, and also we able to achieve the better results. Same way, multi-fan system also. I would prefer to go for first multi-fan system and solve this. Then we can go for VFD also, wherever possible. So these are the simple measures we can do. There are single fan with about 20 HP, instead of that 30 HP. Instead of that, we can put 10 HP 3 fans we can put, and flexible operation we can do. So it depends upon the interest, stoppage. So many things are there. Modification, customer ready to do all those things. Then we can do with these modifications. And false ceiling height and attic space. Attic space also, I think yesterday, day before yesterday, Mr. Ashok Chitram was explaining about the attic space. That attic space, if you reduce, there is a heat load, heat transfer from the solar will reduce. Solar radiation will reduce. You put a fan at the one end of the false ceiling, other end you keep open, so natural ventilation comes and there is a vacuum created. So that heat transfer from the roof will reduce to the shed. So that is also then energy efficient mode. Of course, there are equipment wise, lot of information is available. Lot of companies are there. You can have a comparative chart. You can yourself find out who is producing the best motor, what is the price, what is the copper used, and what is the thickness they use. All these things, parameters, you can easily see in the through you can get the information very easily. So high efficient pumps in the market are available. Then direct driven system, wherever possible you can go, so that belt slippage 5 to 7% are there. We can try to reduce. Cogged belts are there instead of normal belts. Cogged belts also, that also he was telling about the belt drives where we can save. So then the capture velocity and pressure reassessment, what we have done, what is the exact capture velocity required, and at what pressure you want to design the overall system. And air volume requirement also. Sometimes even some machines you want to exhaust the hot air. The machine manufacturer always safety factor, they will give more 1.5 or 2 times. They will tell if there is a CMH of 2,500 CMH required to be exhausted, they will simply say 4,000, 5,000 CMH each machine, like that. So unless we check, we measure it, or we should not go by their words or the catalog. It will be maybe they would have universal one. But we can, if we measure, we know that it is only 2,500 CMH. So based on that, about 10 machine means you're gone. So almost this much 15,000 CMH is gone. So that is going to be over design. This only happens. So unless we know, but without knowing, we just go and do an audit. What we will see for this CMH, they will be telling CMH, okay, motor is taking, fan is delivering. Where we can reduce direct drive, belt drive, that only we will see pressure. But the system exact requirement of the process, once we know, then we can easily we can tell them confidently there is a scope for measurement. And maintenance, one of the things, frequent cleaning and descaling of the water circuit, that is in air conditioning, is main thing. And moreover, they want to, wherever possible, water circuit they want to avoid and put air circuit. preferably soft and water can be used, and pressure and monitoring and control. Monitoring and control now it is as I think some other speaker are going to talk about the IoT and other thermal image and other thing, energy and all. He'll be more focusing on those areas. So monitoring and control, automation control, and BMS for all equipments. So definitely this recording and monitoring is very important for energy saving. So this is what I want to mention. So all the even yesterday he was telling about the instruments. I was surprised because we are just checking all the instruments, calibration, everything. So it was a very important point. He was Mr. Ravindra Datta was telling yesterday about the accuracy, range, all those things. So this happens in the industry. We have to select the correct instrument. The range is 600 degrees centigrade. You check the air conditioning, which is not work more than 50 degree, 80 degree. So that is the range is very important. So that is that's why I think I have given the overall for the understanding of the members, so that we go with confident and we focus on the process, and other things we come in handy for us. I think most will agree with that, because as many speakers were telling only on the process. You understand the process, you focus on your audit, you will be successful. This is what I want to say. I am open to any questions. Just I want to conclude like this. First law of thermodynamics states that energy can neither be created nor destroyed, but if we engineers and professionals apply in optimizing the process and making the material around us viable and derived source, then it could be next impossible thing. This is what I want to conclude. So anybody having any questions, you can just. I think a little bit fast I gone.
No, but it was very nice session, sir. It is very specialized area, so and we don't have that much. It's totally specialized area.
Many of the equipment, other things. I originally prepared about more than 10. It came around 85 to 90 slides, I think. So I did not know that. So then I reduced because I don't know. I was not sure whether time was enough. All those things, but I want to convey the message. That's what basically, because this is the area, because I am also in the Engineering Council of India, where their meetings and all I go, the AICT, all these meetings and all, the members of that meeting. I also try to put like medical professions, doctors, they practice as well as they teach. Almost they will be professors, assistant professors, like that. I admire you academicians. You are really doing energy audit. You people are teaching as well as doing energy audit, and this is a very good area where futuristic. In fact, more, and I think internship and all they made compulsory for students. So faculty development and faculty guiding the students on these things is still it's a long way to go, but really engineering profession we want improvements. Definitely it should be attached with some lab or some research one, like in IIT, or like audit and some with industry. I think in today's news also, Tamil Nadu, they have given AICT approved for 4 labs in Tamil Nadu for colleges. So approved labs for conducting research and other things. So like that, I am delighted to meet you all, and wonderful. It's a good service you are doing overall energy also.
So even what happens whenever we go for audit, no, this is the area which was totally neglected in that industry. Even we saw in the sugar factory, even in the snack divisions, some paper, wherever is there this ventilation, no, it was totally neglected. Somewhere they have installed, nobody's bothered about the filter, cleaning of the filters, nobody checking the pressures. As and when they required, they start, stop. It happens like this. So they are not taking proper care of all this ventilation systems. And they think it is a burden as far as energy is concerned on that equipment or on that industry. Yes. So we tried to we have recommended them even to replace that they have some old fan system like this. So we have recommended to go for some energy efficient fans by giving some calculations. But unfortunately, we don't have proper that members, those who are manufacturing this product, and fortunately we got your contact. Henceforth, at least we can take data or about the design specifications from
Yeah,
your end,
definitely, sir.
or we
Definitely.
can
I am open.
share all
I am
our
open. Yeah,
problem statement.
definitely. Yes, yes.
We'll share our
I am
problem
open. We can
statement all,
interact. Definitely, sir. Yeah, sure, sir. Sure.
and it can be used in the number of the industry, because for the most of the sugar factories everywhere, for the cogen plant, they are using this ventilation system. They want ventilation only for the cogen plant. Huge heat is evolved in that, and there huge big motor pumps are there, blowers are there. Okay, any questions from anybody?
Sir,
My mail ID is there. Contact is there.
Yeah.
oh sir, this is Mallikarjun Kamlyal. Mr. Prakash?
Great. Please,
Yes, sir.
please.
Please.
Yeah, this is Mallikarjun Kamlyal. I have a typical question. I'm trying to recover that particular technical name. I don't know if you could help me out. See, there is one effect where in an air blower, at one point of time, the way how you place your air blower, the pressure, air pressure increases, and at one point of time it becomes zero, and the very next moment it starts sucking air back into the system.
Okay. Okay.
Did you get what I
So
said?
this yeah, the blower in the but is blower is fixed in to some system, no? It is fixed to some
Yeah, it
system.
is a air blower only.
Okay.
They have say, because this is very much required when we define the parameters for a air blower. However best your air blower can be, but unless you work on
Yeah.
those basic parameters, sometimes it starts sucking back the air instead of blowing.
Oh, sucking the okay. No, that could be air balancing, and the system problem is there, means it will reverse. So how it is connected, the suction side or delivery side, how the fan is connected. Based
See, it
on
is on
that
the
only the blower. Delivery side air is has to blow. You mean to say the air is sucking from the delivery side?
Yes, instead of delivering, it starts sucking back at one point of time.
So that means where the system is working, that place there is unbalance. So system unbalance is there. So normally what happens? Positive pressure, negative pressure. We say where is a closed area. You see a closed place. You have a 10 meter by 10 meter by 10 meter. You see from there the air is blowing out. So when everything is sealed, there is a possibility that this air will go out. When if it is not going out, it is coming inside, means from this place, it is from the sealed place, air is going out. So it is drawing more air. So there is a system unbalance, either through some machine or some system. More than the air quantity of the blower, the air quantity from the area, it is going out. So it is reversing. That chances are there.
Some
You mean
sort
to
of
say when
a
the fan is
whirlwind
working
effect.
itself?
Some sort of a whirlwind
That's right.
effect is seen there.
Yes. Basically, it is air balancing, sir. Basically, it is air balancing, unbalancing of the air. You have to balance the air. In a place where you want to do the air conditioning, you have to decide whether you want a positive pressure. For example, in a conditioned place, if you open the door, your air from outside air is going inside, it means it is a negative pressure. When if you open the door, if you can see in some jewelry shop or textile showroom and all, if you before you open, air will be coming rushing outside. They will have given more air inside. So just to attract the customers, it will chill air will blow in our face once you open the door. So it is a positive pressure. So like that, in industry also, certain areas it becomes negative pressure. You go to some industry, you open the door, from outside air will rush. So that is why they have in clean room application and all, they have 2-3 layers of doors, and airtight door they will install. That there will be
There is
a
differential
screen.
pressure that is required. Mr. Prakash, what you're talking is there is a differential pressure that needs to be maintained, mostly
Yes,
applicable
sir.
in medical field.
No, even
More
system pressure is required for any ventilation system. You require system pressure. Otherwise, you will not able to control. From outside, it will be drawing air from windows and other places. It will be start drawing. You have to arrest all these things. That's why that the entire system we have to study. Then we can find out. But in your case, when the fan is working, how it will get the reverse? How the air will come inside? Otherwise, equivalent some machine or fan is something is working inside. That we
See,
have to
I
see.
had seen this, I'll tell you. I had seen this demonstration. I'm not able to recall because every time I try to work on this particular aspect, especially
Okay,
when
sir.
we write our reports, see, you have a
Okay.
air blower in place. and the wind vane that is movable, at one point of time it throws the required pressure and it optimizes, and then it's almost zero. It neither sucks nor it delivers. And you move the thing further, it starts sucking back. Some sort of a whirlwind effect is there in that.
Okay. So is fixed with a motor? The blower is fixed with the motor?
Yeah,
Is
air
it
blower is
visible outside
fixed.
or
Air blower is fixed.
air blow is fixed? Okay.
No.
So any photograph or something is there, so I will be able to help you, sir. Definitely. You can send me, or you note my number. Definitely, I will be able to help.
Because this decides on various aspects whenever we place the air blower on the site.
Okay.
I'm still not able to get, because I had seen in one of the exhibitions. I don't know whether it is Blowpoint or some company, E-Plast, na? There are some companies
That
there
is
who had demonstrated.
that is Baplast. EBM Baplast.
Yeah,
EBM Plus.
EBM.
German
Yeah.
company. EBM company. Yeah. Okay. So
Somebody
they are
had
doing a lot of
demonstrated this
blower
aspect.
fans. Okay. So that so it works on the reverse like that.
Yeah. No, because see,
So
that time we were too immature to understand that aspect. We were not very serious. But now, after having been into the profession, I'm finding that this effect has got a lot of significance when we decide on the efficiency of the blower. I mean, air blower and fans.
Okay. Yeah. Dual there are in fans there are different types are available. So what type of blower they have designed, it is that we have to see. So let me check up. I will also find out. EBM is a German company. Earlier it was with Nadi EBM. Now EBM the joint venture has gone and fully they have come. It's a German company. I know. I have also visited them. So definitely I will find out. Try to find out.
Yes, sir.
It's good information.
Thank you.
Good information. Thank you so much, sir. Thank you so much, sir.
Sir, in between VFD as well as you have suggested something multiple that blowers.
Multi-fan system. Multi-fan system.
Multi-fan system.
Multi-fan system. What I'm telling is single fan. You are having a 30 HP one single fan, and you are blowing air. Instead of that, but requirement may vary. So you are putting a VFD and trying to reduce the air quantity, but the pressure may be constant. There may be we need to know three things. One is what is the pressure drop, what is the total air volume, then what is the total pressure of the fan which is required to work. So when the requirement is less, that time what we are doing, we are trying to put a VFD. VFD means frequency reduced, then RPM reduces. When RPM reduces, directly proportional volume also reduces, pressure also square. So pressure also reduces, cube power reduces. We are happy with the cube, so it reduces. But when the requirement really volume is reduction is a problem or not, that process has to tell. So that's why what I'm telling you, instead of that, if you your requirement instead of 30,000 instead of 30 HP, there is a 10. So you have a requirement of 1/3 of the production. You run one fan. When there is half production, you run second fan. When there is a full production, you run third fan. So always instead of 10 HP, it will work. If there is a flexibility, if this is not a continuous process, that process we have to see. Like that means. But first cost will be more. You are buying 3 fans. So you can't do. There is no space. You can't do that experiment. You can then again there is a direct drive. You can do belt drive again. That is 3 fans slip will be there. So instead of that, you directly go for a VFD. That VFD option is available. Then it will try to reduce. But again, you have to balance the air by adjusting the what happens. They straight away put the VFD and they show the power. But a process, whether what effect it is happening, there can be a heat exchange may not be proper. So that we may not know. There will be inefficiency in other areas, but heat efficiency is not happening. But that may not result because of this customer, or we may think it is not resulting because of this change of the fan. But elsewhere, like that overall, we will see. But we would have saved the fan power. Actually, but by saving the fan power, we have compromised on the heat transfer or something. That we have to 100% we have to ensure it has not happened. For that, we have to see the velocity of the air or area of the duct, all these things ensure. same output, if we are able to reduce with VFD, that is fine, fantastic. We will be able to do. That means design itself we remodified, and VFD, that is perfect. So that's why the VFD, energy auditor, original designer, process person, maintenance, all should go hand in hand. Then only we can succeed. So cost of the ownership, they will get benefit. Otherwise, we can pat ourselves, they will pat us.
True, sir. It is true.
This happens in
Any
industry.
question?
Straight away.
Any question
Yeah,
from
any other question?
participants?
Anything is there, you can ask.
Yes.
If I know, I will tell.
Even they can share to our WhatsApp group or directly to you also, and you can further communicate. You can respond also.
Yeah, definitely, sir. Definitely, you can add me, and I have given the both the
All
Gmail
details.
and as well as my company mail ID and mobile number. If anything is there, they can contact you. I am
Yes.
so much thankful to you, sir, and your team of people who have done excellent arrangement for this one. I also enjoyed the other speakers, and I am also eager to listen to other speakers further on
Great.
the sound system, and also HVAC. Something is there on the healthcare, and also water audit also. I am very much interested on that also. Thank you so much, sir.
Yes, sir. Thank you. It was really nice.